Dear student, this is a lecture series 7 of Z transformation, and in this video I am going to discuss time delay property of unilateral Z transformation. Here, if Z transformation of xn is equal to xz, here U subscript stands for unilateral Z transformation, then Z transformation or unilateral Z transformation of xn minus n naught is equal to z raised to the power minus n naught xz plus z raised to the power minus n naught summation n varies from 1 to n naught x minus n z raised to the power n, while n naught is greater than 0. Now, by definition, Z transform of x n minus n naught is equal to, because we have already mentioned this is a unilateral transform, so n varies from 0 to infinity, x n minus n naught z raised to the power minus n. Let m is equal to n minus n naught, then limits will become, if n is equal to 0, then m is equal to minus n naught, n is equal to infinity, then m is equal to n infinity. Now we'll put these value in this expression. In this expression we get m is equal to minus n naught to infinity xm z raised to the power minus m plus n naught. Now we can break this limit m is equal to minus n naught to infinity as minus n naught to 1 and 0 to infinity, like this. M is equal to minus n naught to 1 and m is equal to infinity. Afterwards we can see this, we can write it xz, and if we'll see that, we can write it like this: m is equal to 1 to n naught. This is m is equal to minus n naught to minus 1, so we can write it like this: 1 to n naught, and minus we can write here x minus m z raised to the power m. So we can write it like this: z raised to the power minus n naught xz plus z raised to the power minus n naught summation n is equal to 1 to n naught x minus n z raised to the power n. Now, for example, if we'll take n naught is equal to 1, then we can put z unilateral transform x n minus 1. We have put n naught is equal to 1 here, then it becomes z inverse xz plus x minus 1. Next, we will discuss initial value theorem. According to initial value theorem, if xn is a causal, or we can say xn is equal to 0 for n is less than 0, then x0 is equal to limit z tends to infinity xz. Now, by definition, xz is equal to summation minus infinity to infinity xn z raised to the power minus n. Since xn is equal to 0 for n is less than 0, so we can write like this: n is equal to 0 to infinity, because for n is less than 0 xn is 0, so we can write like this. And once we will expand this series, we can write n is equal to 0 x0 plus n is equal to 1 x1 z raised to the power minus 1 at n is equal to 2 x2 z raised to the power minus 2, in this way up to infinity. Now, taking both side limit z tends to infinity, then it becomes limit z tends to infinity xz is equal to limit z tends to infinity, and this series like this. Now, if we'll put the value of z tends to infinity here, then this will become 0. All these terms will become 0. Only x naught will be left. So we get limit z tends to 0 xz is equal to x naught. This is the initial value theorem. Now I'll discuss final value theorem. The final value theorem states that if limit n tends to infinity xn exists if Z transform of, here subscript u stands for unilateral Z transformation, xn Z transform of xn is equal to x. Then limit n tends to infinity xn, or we can say x infinity is equal to limit z tends to 1, 1 minus z inverse xz. Now let's start with the proof. Let's take the unilateral Z transform of single signal xn minus xn minus 1. So we can write like this. Unilateral, U stands for unilateral Z transform of xn minus 1 is equal to, we can write the formula here from the definition, summation n is equal to 0 to infinity. The point is, when it is unilateral, then limit start from 0 to infinity xn minus 1 z raised to the power minus n. Now we can apply separately Z transform of xn minus Z transform of xn minus 1 is equal to limit n tends to infinity summation n is equal to 0 to n, because here infinity is there, so we can write here n and limit n tends to infinity. We can write xn minus 1 z raised to the power minus n. Now Z transform of xn can be written as xz minus, now Z transform of xn minus u, from the time shift property that we have just discussed, then it will become Z inverse xz plus x minus 1 is equal to limit n tends to infinity summation n is equal to 0 to n xn minus 1 z raised to the power minus n. Now taking limit z tends to 1 both sides, then it will become, if we'll take xz common here, then it will become 1 minus z inverse xz minus x minus 1. Limit z tends to 1, limit n tends to infinity, and this. Once we will expand this expression, then it will become like, we will put the value of n is equal to 0, then it will become xn minus x minus 1. When like this, if we'll take n is equal to 1, then it become x1 minus x0, x1 minus x0. In this way we will expand it up to n, so it become xn minus 1 up to n. Now here we can see that x0 will cancel out with this minus x0, x1 will cancel out with this x minus 1, and in this way we, only two terms will be left, that is limit n tends to infinity minus x minus 1 plus xn. So here limit z tends to 1, 1 minus z inverse xz minus x minus 1 is equal to, will apply limit n tends to infinity, there is no n, so it will come out of this bracket, and limit n tends to infinity xn. So this x minus 1 will cancel out both sides. So this is the final value theorem. This is limit z tends to 1, 1 minus z inverse xz is equal to limit n tends to infinity xn, or we can write it like this, x infinity. Hence proved. These are the reference books for signal system course, and thank you.